Okay, YouTube, in this video we're going to look at a final and primary way to solve a quadratic equation, which is by using what we call the quadratic formula, which is one of my favorite things to use because it is usable whenever you have something that is a quadratic equation in what we call general form, which means we have this ax squared plus bx plus c equal to 0 specifically. So the nice thing is, with the quadratic formula, if we have something in this form and we can readily identify a, b, and c, essentially we can say that as long as a is not equal to 0, then we have the solutions to that equation are always x equals these two numbers right here. And I suppose that what I want to point out here is this. We get two numbers from this conclusion because when we take the square root of something, we get a positive root and a negative root, okay? So we get that x will always equal negative b plus or minus the square root of b squared minus 4ac, and this is all over 2a. And essentially what I want to point out here is this. If you did not like completing the square in the last video, which we still have to know how to do, essentially what this is right here is what you would get if you were to solve this equation by completing the square in general with a, b, and c not equal to numbers, but just equal to variable values. You always get that x comes out to be this. So this is nice because you can just bypass all the completing square, identify a, b, and c, and then plug those into this formula to find the values of x for which this equation here in this form would have to equal 0. So what I want to do is just kind of put this to use in this video here, and we don't have to spend a long time talking about it. Let's go ahead and look at this equation right here. We notice that already it's set equal to 0, which is the most important thing to denote in the first place, and that it's in standard form, okay? This wouldn't work for something like x minus 2 squared equal to 0. We'd actually have to FOIL that out and say x squared minus 4x plus 4 equals 0 before the quadratic formula would work. But we have an a value of, it looks like 2 here, positive 2, a b value of positive 2, and a c value of negative 1. Whoops, I'm already thinking negative 1. We say positive 2, c is negative 1. And if I'm going to use the quadratic formula, I'm just going to go ahead and indicate those and put a box around them. So let's go ahead and set ourselves up here. Now I'm a big advocate for when we're doing substitutions, we use parentheses inside which we will substitute. So we have 4 times a times c all over 2a. And so if you're saying, hey, you know what, actually, let me get this out of here. This is a minus 4ac. If you're saying this is a lot to remember, well, let's remember it. I mean, you're going to have to take a moment to stop and memorize this bad boy. So we'd say, okay, well, it looks like we have a b and a b are these first two quantities. And we know that b is equal to 2. So I'm going to put in a 2 here and a 2 here. And then these next two quantities here and here are a's. I witnessed that a is equal to 2, so I have a 2 and a 2. And then this very last number here is c. And in this case, we get a negative 1. So now I can say, well, right now, these are the solutions to the equation. Congratulations, I'm done, right? Well, no, we actually have to simplify this. So that's about the only hard part of doing the quadratic formula. So let's go ahead and simplify this. We get negative positive 2, which is negative 2, plus or minus. Now, I know that the easy parts to do would be this first number here, this negative b, and the bottom part here, 4. The thing that tends to throw people is what's on the inside of here. And I don't even mean this 2 squared here for our b squared. That's certainly 4. But this negative right here, I don't know why. It just tends to confuse people sometimes. What I want to look at this as is we're taking a negative times a positive times a negative. And these two negatives right here would cause this to be a positive value. So now we can just multiply these. We say 4 times 2 times 1 is 8. And so our solutions here would be as follows. We say negative 2 plus or minus the square root of 12 all over 4. So here comes the simplify part. I notice that 4 is a factor of 12, which means we need to simplify our radical. We'd say this is 4 times 3 all over 2. Furthermore, we could say that we get negative 2. Now, the square root of 4 is 2. So we say negative 2 plus or minus 2 times the square root of 3 all over 2. And I notice that everybody has a 2 in common, but essentially, when you simplify a rational expression, remember you factor the top and bottom. And I notice at the top here, we could factor out a 2. So if I take a 2 out of the top, I would be left with negative 1 plus or minus 1 times the square root of 3 all over 2. And so these 2's cancel now, and what we're left with is that x must be equal to negative 1 plus or minus the square root of 3. That's what we would get here. So these are the two roots that we find here, and just to be clear, we should write this in set notation, but we say our two solutions to this equation are these right here. And we could go verify that graphically these are the x-intercepts. So for this last example, we'll go ahead and take a look at another one here. We have a, b, and c. Let's go ahead and start by listing these values of these quantities here. We say a, b, c. A is 1, b is negative 2, and c is 2. So put a box around these. And again, we'll just go ahead and fill in some blanks here. We say x equals negative b plus or minus the square root of b squared minus 4 times a times c. And this is all over 2 times a. So let's start with our b again. We get negative 2 and negative 2. We have a and a, so we say a is 1 and 1, and then c is a positive 2. So here we go. We say out front we have negative negative 2, which is a positive 2. And this is plus or minus the square root of something all over 2 times 1, which is 2. So looking in here, we get negative 2 squared is 4. Now, negative times a positive times a positive. This actually comes out to be negative. And 4 times 1 times 2 is 8. Yikes. I don't know if you see why I'm saying yikes yet, but what I end up with here is this, a negative inside the radicand. So we say 2 plus or minus the square root of negative 4, which doesn't really ruin my day, but what it does mean for us is that we're not going to get real results here. So what we end up with is a situation where we have 2 plus or minus I times the square root of 4 over 2, or in other words, we get 2 plus or minus 2i over 2, and factoring the top here, we get the 2 out, we say 1 plus or minus 1i all over 2, and the 2's cancel, and so our solutions are these. We would say the solutions to this equation, which did not factor, we needed to use the quadratic formula or complete the square, are 1 plus or minus I. This would also mean, while we're at it, that this parabola would never hit the x-axis, would have no real x-intercepts.